Question 7.37 says, identify the major and minor products that are expected for each of the following reactions. So the first one, I'm taking this alkyl bromide and I'm treating it with sodium chloride and DMSO. So if you remember, DMSO is dimethyl sulfoxide, so it's a polar aprotic solvent. So polar aprotic. And then if I draw out the ions, sodium and chloride. So chloride falls under the umbrella of being a weak base but a strong nucleophile. And my alkyl halide is a secondary alkyl halide. So in this case, SN2 is going to predominate because I have a good nucleophile, chloride, but it's not a good base. So I'm not going to get any elimination. And if you remember, SN2 reactions are going to predominate in a polar aprotic solvent. So if I want to draw the curved arrows for this reaction, which aren't asked for, but it's always fun to draw them in. So I'm going to get a nucleophilic attack, and then the loss of my leaving group, that's going to happen simultaneously. So if I draw my final product, I have 1, 2, 3, 4, 5 carbons, and I invert the stereochemistry like this. So I replace the bromide with a chlorine like that. So I end up with this chloro compound. So if I swap out for my blue pen here, there we go. So in the next one, I have a tertiary alkyl halide, so tertiary alkyl halide, and then I have sodium hydroxide. And hydroxide, OH minus, is a strong nucleophile, and it's a strong base. But it's not going to behave as a nucleophile with a tertiary alkyl halide because it's too hindered. So I have a strong base, I have a strong nucleophile, and a tertiary alkyl halide. So if I go back to my figure 7.20, the mechanism that's going to predominate will be the E2 mechanism. But you can see that there's two types of beta protons. So if I label, this is my alpha carbon, there are the beta protons on the methyl groups, but then there's also beta protons here on this methylene as well. So if I draw the elimination, if I was to remove one of these protons from the methyl group, I would end up with this compound. So I end up with this alkene. However, if I was to remove the proton down here, then I would end up with this regioisomer. So I can end up with these two possible regioisomers, but this one would be the major product because my base isn't hindered. So since it's a non-hindered base, I'm going to be able to form this product as being the major product because it's the most substituted. So we could put here the most substituted because this alkene is tri-substituted, whereas the one to the left of it is di-substituted. So if I find my red pen here, there we go. Let's take a look at the last one. So if you remember TBUOK here, what that stands for is tertiary or T-butoxide. So, sometimes we'll just draw it like this. Okay, so this would be a bond line structure. Okay, another way of drawing this is to draw the whole, to represent all the methyl groups. Okay, so what I'm getting at here is that this is a big, bulky base. Okay, this base takes up a lot of space. So therefore, it's going to preferentially pull off or abstract the least hindered proton. So I have a tertiary alkyl halide. This is tertiary, and I have a strong base and a strong nucleophile, but it's way too encumbered. The tertiary alkyl halide is way too sterically hindered in order for a substitution reaction to occur. So I'm going to get exclusively elimination. And there's two types of beta protons. There's the beta protons that are on the methyl groups, and then there's also this beta proton here. So since this is a hindered base, it's going to preferentially pull off this proton here because it's the least sterically hindered, and thus the major product in this specific case will be the Hofmann product. So this is the major product, and this is the Hofmann product. Okay, and then my Zaitsev product is actually, even though it's a more stable product because it's more substituted, right? The Zaitsev product is tetra-substituted, whereas the Hofmann product is di-substituted. But the reason that this is the major product is because of the hindered nature of this base. So there we go, like that. So hopefully that helps with questions A, B, and C in question 7.37.